Okay, so I think we should get started here now. Good morning, everyone. Welcome to this first tutorial class for intermediate rigging. I noticed the weather was a little concerning. It could have been a little snowy by the time this was done, so just having this online makes sense, and I'm sure no one minds having tutorials online. Right into it. If anyone does have any questions, always feel free to raise a hand or turn on your mic and say anything you need to, because I'll be more than happy to oblige. And yeah, let's get into this. So, tutorial 1. First of all, always a thing I like to do for these is always give myself a little introduction. So, hello, who am I? I am Josiah Cabral. So I am a 4th year student here at Ontario Tech. I am a 3D artist. That is my passion that I found throughout this program. I love rock climbing, as you can see in that bottom left photo there. That's me in May in 2025. It's a really fun climb I did. I play the drums. Those are my drums there with a nice light on them. And I love VR a lot. Those are the 2 headsets I have. I still have my Quest 2 and my PSVR. I didn't get rid of them yet, or my PSVR yet. Just keepsake. But yeah, I use it pretty often still on my computer. And yeah, so what do I mean when I say I'm a 3D artist? So there's 2, I guess, categories. I'd say there are things I'm proficient in and things I'm sufficient in. So proficient meaning great at. I'm really good at environment art, technical art, texture art, level design, just anything more environment based is kind of my strong suit, right? So large scale things, atmospheric, I'm really excelling at. But sufficiently, which means I'm good at, is character art, sculpting, concept art, and rigging/character animation. So what this entails is I do know my ways around this class, like rigging and everything. However, it's not my main focus, so just keep that in mind, that I'm going to be also trying to remember things as we go on, because I do this every once in a while, rigging, and I'll show you what I've done like in the class 2 years ago at this point. But we're all learning together, so if I might not always have an answer to questions, and that's okay, and I'll mention that later on, right? But I'll always make sure to come back to you on things, and it'll be a very fun process throughout the semester. And here are just some other environment art pieces I worked on. The one the one at the top here is my newest one. I worked on it during the Christmas holidays. It's a fan art piece I made for Teamfight Tactics. So I made a little board here just to kind of really demonstrate my hand painting skills. It was very fun, very intense, but it was well worth it. You can see at the bottom left here is like my 2nd year project, this is the time when I did this class you're doing right now. And I believe I'm the only one in the program still that took this course, because I don't believe it ran last year, so that's funny. And then at the bottom right is just one of my library pieces I made. And you can see this is all on my ArtStation. So if you ever want to look at that, you can just find that through my Discord, or just search up my name on ArtStation. You'll find it there. Contact info. Tutorials are at this time every week on Wednesdays, from 8:10 a.m. to 11 a.m. in the Science Building at 2230. So every other time should be in the Science Building, not online. DM me on Discord and I'll respond as soon as possible. I usually see them quite often because my Discord's always open when I am on my computer. If you do send me something through Canvas, it's very possible that it will just be lost into the shadow realm. So I'd recommend you to send it straight to me on Discord, whatever message is. All right, so I'm gonna take a quick sip of my water here. tutorial structure. I figured out a nice system during the modeling 1 TAing I was doing of how to kind of approach doing these tutorials. So I like to do it in 3 main sections, which I loosely follow. I don't always do it in concrete, but for the most part, it follows this, where it's part 1, which is the review on section, which is solidifying your understanding of the lecture material and reminding you of the crucial tips and shortcuts. Just things that are most significant to your learning, I will reiterate on. We can expand on that just to talk about it all the way through. That's more talking and showing. The second part is build on, which is sort of a follow along while I teach you a valuable rigging topic, applying these specific topics to different rigs and models. I do believe that there might be a bit of separation between what Gavin and I are going to be doing at some points, because I believe Gavin will be doing more of the face rigging and I'll be doing more of just overall armature humanoid rigging, not just humanoid, but just the full body rigging. And so I will be able to, what I plan to do, which I'll show later, is take what we're learning and then apply it to my own 3D model, like that to rig and everything. And then the last section is just the work on period, which is your time to work on class activities, assignments, and this is the time I'll be hovering around to anyone who needs the help. This would be in person, and so that would mean I would just be chilling in the lab, just walking around everyone, seeing how everyone's doing. But for today, I'm just gonna be sitting in the call as long as I need to. So yeah, those are the 3 sections. Lab activities. So I have not posted any of them yet because it's still figuring them out exactly. But there are going to be 3 in-class activities worth 5% each. Ideally once every month, starting in maybe February. Yeah, probably February. They will focus on introducing / expanding on a rigging topic that would benefit your rigging workflow. They will be due, this is the deadline I've set for now. It's going to be Tuesday night following these lab activities, giving you all a full week pretty much, to reach out to Gavin and I for help. So I feel like that's enough time. And the main thing is that we're going to be trying to complete this during class time, because I don't think you would want extra homework, extra things to do. So these should be hopefully quick enough where you can finish it in class time, if not a little later. But yeah, these are going to be focusing on some simple part of your rig. Like, I believe the assignments that in their current state, they're related to arm rigs and just creating like a very simple arm rig. Nothing else, no other body parts, just the arm. And then the second lab is expanding on that arm rig. And then the third lab is making this unique rig with, it's like this stylized tentacle creature thing that you can just, it's really fun. And yeah, that's gonna give you more information about that later on. Slide format, it's going to be following the same format as modeling 1 for cohesion, and I think it worked really well. If you took that course, you would remember these. The orange text is always going to be hotkeys / important details, so just keep that in mind. It would help to know like what's important, what's the most significant in the slides. So we're all done with the introduction stuff. Always put your hand up if you have questions. Just let me know and I'll be more happy to answer them. But we're just going to head into the next part, which is rigging. So before we even get started, could I get hands up of how many people have done rigging before? All right. So I believe 7 hands. It was like 7 hands. Yeah, okay. Yeah, basics. Yeah. If anything, it's good to start from scratch, and it seems like about half, a little less than half of you have some experience with rigging. This course is a little broad in the range of, people that know rigging, there's people that are very new, people that are more experienced, in the middle. So we're just going to start slow. We're going to just go. Today's going to be all about going through terms and just inspecting kind of what you did in the first lecture last week, but a little different. We're not going to look at the same model. We're going to look at a different model. And I'm just going to go through some terms here before we do that. So before that, actually, the goal for the semester, this is my work I did 2 years ago this was in Maya, but we're all using Blender. So don't do this. I was kind of stubborn and I didn't want to use Blender, and I do wish I used Blender back then, but a lot of the same things will apply. Actually, everything will apply still. And it's actually going to be easier for you than how hard it was for me to figure out things in Maya when we were learning in Blender. So ideally, we would want a rig like the one on the left side by the end of the semester. It doesn't have to be humanoid. It's going to be probably something related to your game or something that you just are passionate to make. And that's the goal, to get there. If we don't get all the way to making a full rig, that's like what it's going to be okay, but we're just trying to build out that process of going from concepts and then building those V-forms, those controls, all the different drivers and everything, and just showcasing that the process. That's the most important thing, and hopefully we can get to a result like this. That would be ideal, or that would be nice. And then here I showed some stretching from this is the model for my second year game, and then just these are the face bones that I made for one of Gavin's assignments. And yeah, I believe I did do a little above and beyond for these submissions, but yeah. This is you in intermediate rigging. This is my favorite slide from when Marcus was teaching this 2 years ago, so I just kind of kept it. You are kind of putting on your engineering caps a little bit. You aren't as artistic in this class. It's still like 3D, a 3D class, but it's not as art heavy. So you're gonna be much more head trauma. I think at certain points you might have a bit of some headaches, so this implies that you need some protection on your head from that. Yeah. Rigging's technical, so be willing to reach out to me and your peers for help. We have a lot to learn from each other. I'm not the most proficient at rigging, as I stated, and that's okay. As you can see, I still was able to get the results that I was hoping for, right? But it's not my focus. It just takes your time. That's kind of what it is. It just takes time, and rigging can be confusing, painful, and in my opinion, it's a bit boring. It doesn't click with me the same, but in the end, it's well worth it when animators, you included, can create incredible animations at a very rapid pace, versus having what I did in my first year was I had made a rig with just the deform bones, and so there was no control rig to use, and I had to just animate everything on the keyframes, every single bone. It was such a headache, much more of a headache than rigging in the first place. So yeah, making rigs is gonna save you so much headache later on, and rigging is fascinating to observe. Seeing what rigs interest you and learning from them is such a good way to be inspired and to know what to look out for when you're making a rig. For example, it's pretty easy to find humanoid rigs and learn from them, but then what's also helpful is looking for humanoid rigs that maybe, if you're trying to rig a certain character, that have a very similar body structure to your characters, so that you can see, how do they compensate for the bigger shoulders or the certain large gut or whatever your character has. Or even if you're making a quadruped, right? And then you're like, how do I do this? You need to find a rig that is a quadruped, right? Things like that. Looking at how people did it helps a lot. And we want to develop a process. Your rigs and models, your rig/models can be far less substantial than the ones I showed, as long as you clearly demonstrate the topics learned in a collective effort, and you're meeting what the expectations are in the assignments. You will do well. Rigging takes many small technical steps, so be patient, take your time, and don't do it all at once because you just get overwhelmed, right? And rigging is a back and forth process. You might have to go change some deform bones or some controls later on if something's not working, and that's okay. Blender's pretty good at kind of being very back and forth like that. You don't have to do it all in one exact line or exact path, but it does help to start at the basics and then move from what is expected to be the first steps. So we're going to review quickly on the lecture content. When I watched the lecture, the main things I wanted to take out of that was just kind of solidifying the things we saw that made the most sense to kind of ingrain in our minds, like the certain terms, like what is this part of the rig, and what's the name, what does it do. So here are some of the main parts of the rig that we were seeing on last week, and just in general, these are the kind of terms and parts of your rig that it's gonna help to remember those names. So starting off, the top two over here are your deformation bones and your control bones. So the deform bones these are the closest link to your rig itself. They are what control the mesh through weight values, which I'll touch on a little bit. And these are the things that you then do all your rigging from. So this is the base, the foundation of your rigging model. And all the visual side of your rig is from here. So these are the foundation. And then second, we have control bones. Control bones they control, it's in the name, they control the deformation bones. And they can look just like bones. They can have interesting shapes, which I'll talk about later. And the point of them is to control the deformation bones, which the deformation bones control your model itself. So just kind of, you can see that we're sectioning off the rig into different, the rig into different layers. And then right here even, we have our bone layers. Bone layers are just the sections of your rig that you can enable and disable with like collections, or I believe this is a custom tab that was created, and I'm not too sure if we'll touch on making a custom tab in Blender, but I'll just make sure of that. That's a way to hide certain parts of your rig so that there's less clutter on your scene, which makes it easier to rig and also animate. Next, we have bone constraints. These are very helpful because they constrain your bones into certain axes or certain transform properties or certain limits to prevent your rig and your entire model, for that matter, to getting way off proportion or off center. If you don't want your arm, let's say, your arm rig to bend beyond 180 degrees, you can limit to stop here, and then it just can't keep going, right? So constraints are essential. Then we have drivers. Drivers are a little more technical, but pretty straightforward. It's essentially assigning one object and their transforms or their properties to drive another bone armature's transforms properties, right? So it's a way you can, let's say on your screen you have like a couple controls that look like switches. If you switch it down, the driver may change a property on your control rig to do a different property, to change from FK to IK to FK, for example. These are great. We're going to touch on those eventually. Not sure how soon. And next is mechanical bones. So I just used the bendy bones here, for example. Mechanical bones sort of are interesting ways to manipulate your rig, right? I don't know exactly the definition, but for the most part, they are parts of your mesh that you can just kind of manipulate in unique ways to get interesting results, such as bendy limbs and whatnot. And then we have control widget shapes, which are pretty close to control bones, but they are these curved shapes, circles, squares, cubes that you've seen before, that are custom shapes that help you understand what parts of your rig you are deforming or you're going to animate. It's very visual. It's just kind of a UI. Think of like a UI that you're creating for your rig. And then we have bone relationships, which are, this is the parent-child relationships that bones have with each other, and this is essential for having limbs that move in relation to one another. And then we have weight values, or weight painting, which is painting the weight of vertices to those deformation bones, which we talked about earlier. And this is how, when you move the armature, those vertices will move based on their weight values. And then finally, whatever custom properties you desire, at some point we're going to be talking about making custom properties, and I believe that would entail using Python, which I know it's scary, it's very terrifying, but it's going to be very simple, and it'll just be like little things to help with your creating your rig and everything. And that'll be very far down the line from my knowledge. So there is this incredible tool, or this website, the character library, where you can look at different rigs, which Gavin did showcase. There are these other ones here, but I believe you need, like this one here. I believe you need to sign in, and I did not want to sign in and make an account with them to get their models or to view a rigging model. So I just went to the Blender character library and poked through some of these. So now we're going to build on our knowledge. So we saw a lot of things that maybe mean nothing to us, that are like, this is overwhelming, and I've been there, trust me. And what we're going to do now is we're going to sort of expand on what we've learned so far from last week. Before that, do we have any questions? Yes, I believe I fixed it now. Can I get a confirm on that? Yep. Yeah, that happens. I think I need to update my computer. Sometimes the audio just gets delayed, and it's really frustrating. I guess my mic might have cut out too. It happens every once in a while. Yeah. Did you miss anything when that happened? Or is it okay? Okay, good. Well, thanks for mentioning that. Okay, so now we're going to be building on our knowledge. So the process. What's the intention when we were making these rigs? So rigging, I kind of sectioned it into these 3 parts here. And this is kind of in the book that Gavin recommended you to have for this class. So there is functionality, which your rig needs to work as expected, right? And so starting with a basic bone structure and then detailing later is ideal. The user experience needs to be considered. It needs to be easy to use and hard to break. You don't want just headaches for the user, the animator that's making your rig and everything. And then deformations, it needs to look good. It needs to produce good looking poses, right? And require little cleanup later, right? So functionality, user experience, deformations. This is the humble bone, the bread and butter, the main course of your entire rig. This is where you start from. This is what you do this is how your model moves. It is the bridge between animations and 3D models, right? At least this is the way that has been created over time as the most effective for animation of characters and models and anything. The head is, so we have 3 parts here. We have the head, the body, and the tail. The head is the parent that everything else transforms based on. The tail is a child of the head, and I'll tell you what that means in a second. And then we have the body, which connects those two visually. So this was a struggle I had with Maya when I was using it, because there's only the head. There's only one. This is the only part of the bone in Maya. There's no body and then tail. So it's much more confusing to figure out how to rig in there, because it looks very different. It's just little dots and you have to connect the dots, right? But in Blender, it's very visually pleasing and easy to understand the connection. So there are different ways to view the bone. By default, we have octahedral, which is this shape here. And that's ideal for most circumstances, but you might run into situations where you want to use different options like stick, B-bone, envelope wire, and you can change it in the viewport display and then display as. And then we can adjust bone transformations in the end item tab while in edit mode. When you are in, let me see if I can show it here. So this is my scene that I've been just messing around in. Oops. If I place a new armature single bone, you can see there's this tab here. Under item on the end tab, there is the head, which is right here, which is set to 000, and that 000 is based on the armature itself. So whenever you place a new bone, it can't be on its own, like it can't just say bone, it has to be a part of an armature. And so the armature will have all the bones inside of it, right? So you have armature and then all the bones within the armature, right? And so by default, it's octahedral. If I go click on it, scroll down the viewport display, you can see I can change it to stick, B-bone, which B-bone will be for bendy bones, envelope, very interesting looking. Don't know exactly the use for some of these, and then wire. I guess it's just for visual clarity. And so there are very simple, pretty simple transforms here. We don't have to worry about these as much, but it's good to know the relationship between the viewport and these bones up here. So if I move this around, you'll see the head transform changes. If I move the top here, the tail transforms change. If I change the radius, I believe nothing happens. Don't know why. If I change the roll though, the bone visually rotates like this, and this helps you kind of make sure your orientations are set properly, right? Or it might just be visual, not too sure, but that changes the rotation like this. The length changes the length, which will move the tail along the Z axis or whichever axis it's facing. And then envelope is for envelope weights. which is a certain type of weight painting, which I don't know exactly how that works, but usually we don't use that one anyway. Right. And so next is parent-child relationships. These are, you might already know this somewhat from, let's say, the Blender or the Unity hierarchy, where you have like the parent objects and then you have like the children underneath it that move, that are transformed based on the parent. So these are very essential for your rigs, because these hierarchy-based relationships are incredibly useful for saving time on transformations. If you move, by default, a single bone would operate on world space, which means it transforms based on just the world origin. But then when you have bones all parented together in a hierarchy like this, the children operate on local space, which means it's far easier to work with transforming, because they pivot around the tail of the parent bone. The head parents on the tail of the parent bone. Yeah. And so this kind of works like your bones in real life, in your body, right? You have, let's say, if you can see my arm, and the shoulder joint here is the parent of the rest of the arm, and then you have the elbow. So if I rotate my shoulder, the rest of this, my arm is moving in globally, it's moving in global space, but in local space it's not moving at all. It's just pivoting. It's only rotating around, but even then it's not even rotating. It's following the transform of my shoulder, right? And then if I bend my elbow, my arm isn't really, like, my hand isn't really moving. It's my elbow that's moving, and it's moving everything with it. And those save you a lot of time from having to animate every single bone separately, because you can just move one and then the rest of them move along as well. So rotations. This is a topic that I feel like should be discussed right away. So by default, Blender, so we have Euler and Quaternion, and it's important to know when to use each. So Euler is easy to understand. It has 3 numbers to track, one for each axis. It looks great on the curve graph as well, because there's only 3 axes, and it's great for single axis rotation, which I'll get into later what that is. The cons is that it can be gimbal locked, which means when multiple, so I'll talk about that when I'm in Blender first in a second. It starts to get weird when you introduce more than one axis of rotation though. And then Quaternions have no gimbal lock, handle multiple axis rotation better, and have better flexibility overall. The cons is that it's literally 4-dimensional, so it's in WXYZ, and that makes it hard to read on the graph. And so if I go into Blender here, you can see that right here, the rotation, X, Y, and Z are all, you can see here the mode is XYZ Euler, which means that it's first going to rotate, like when it's doing calculations in Blender, it rotates the Z first, then the Y, and then the X, right? But because it's kind of like a parent-child relationship in its own right, because when Z rotates first, it moves Y and X with it. So if Z is pointing straight up, and then like you have Z and then Y and then X, if you rotate Z, you see all of those other rotations move with it, right? And then if I move, let's say Y, which is straight ahead, and then you move the other axis, they're all going to kind of affect each other, right? And you can see here now that Z and X are rotating along the same axis. And it's like, how can I, that makes no sense. How can I rotate any other direction now? It's kind of, it gets really weird when you're doing many axes, right? But when you're just rotating in that viewport, Blender will automatically fix those weird rotations for you, right? You can do like along X or along Y and whatnot. And Blender should automatically fix those weird rotations, but when you're doing rigging, it's not going to know how to do that. And so you're going to get that gimbal lock, gimbal lock pretty quickly if you're doing multiple axes. And I'll tell you what use cases there are for each of those. And so quaternions, we'll get into how to do those eventually, which is right here. And they're confusing because there are 4 axes and I don't fully understand exactly how to do them either. But you can see that it's much more precise, and it's not, because it's 4-dimensional, it will not get stuck like that. It'll always be able to rotate every direction, right? So choosing based on the situation is important. Euler is great for a single axis rotation, like your elbow, because your elbow is only going to ever move or rotate like this. Some examples are finger clenches, elbows, knees, foot rolls. If you separate them, if you do 2, like one for the x-axis, one for the y, or whichever axis it is, anything that's in one direction is very good for Euler. And then next is quaternions, which are great for multiple axis rotation. If you aren't sure what to pick and it seems confusing, try quaternions. The shoulders ball and socket joint is a perfect example of this, because your shoulder can rotate up and down, forward and back, and then it can kind of twist a little bit, very little, but it has much more freedom of movement. And it's better to decide these early on, as you see, to change it. It might not be here, but it would be, you'd find the proper location to change the mode of axis. Because if you don't do this and you're far into your rig and you're like, I need to change this later, it might mess up a lot of your constraints and whatnot and your drivers with the new axis involved. So naming conventions. This is how you stay organized. This is not just for rigging. This is for anything you're doing. Not even just 3D, just naming conventions are very important. Especially though for 3D when you have a lot of objects in the scene. And especially for rigging when you have a lot of different bones. And a lot of the same bones that are used for different things, right? Like you can have the exact same armature for deformation bones and then the exact same one, but it's all control bones and then mechanical bones, right? And so it's important to know what each one is. And also you'll have the same name for both left and right limbs. So it's important to add the prefixes and suffixes to differentiate that as well. And here are some examples, just off the top of my head here. You have def for deformation bones, which are, once again, the bones that are deforming the actual armature itself or the actual mesh itself. IKFK, which is inverse and forward kinematics. You can label IKFK at the beginning, or just IK, or just FK, to help whoever's rigging or animating know that that bone they're grabbing or that control is a IKFK. And then MCH is mechanism bones. And then control is control bones. WGT, widget or custom shapes. Widgets are, once again, just the visual, it's the name of the visual shapes you can make for control bones. It can help to differentiate it. And then suffixes, which is meaning at the very end of your name. you have _L, left bones, _R, right bones. And then you can choose exactly what you want to do for chain bones. Like if you have multiple bones in the spine, you might want spine 01, spine 2, spine 3. The main thing though is whatever you decide on for any of these prefixes and suffixes, you want to stick with that throughout every single bone in that rig, right? Because it helps a lot when you can rapidly search up every single bone of a certain type, or of a certain, like every single deformation bone very easily, because in here you can just type in DEF and then just see all the deformation bones like that. Let's see if I don't think I have any other. Here we go. Oh. No, I don't believe I have a rig in here that I can look at its different bones. But they're gonna have all these different prefixes and suffixes, so it's easy to find what part of your rig that you want to look at. And as I said, it tremendously improves our rig's organization. And we want to pass this to our animators later, so we don't want to make it hard to understand. We want to make it easy at a quick glance for the animators and for other riggers too. Alright, so that's all of the terms I wanted to talk about for this first lecture, or this first tutorial. Here's a helpful tool for you that I've been using since my first year, and it's been a blessing. So this is GIFcam. GIFcam is the best for recording your own GIFs of your submissions. I use this to instantly create all the GIFs that you saw throughout this tutorial, and even back way back. Let's see. I use GIFcam to make all these GIFs here, right? I preferred making GIFs because it's easy to control the frame rate, the different parameters you can tweak, and the size of your window and everything. It's very good, and it makes small file sizes versus making videos, right? It's a good in between making photos and videos, and I can quickly showcase it. So and it's very fast to open and everything. So you can see I have GIFcam here. Oh. And then if I scale this down, it changes the resolution. I click on this little arrow here. I can change. I usually do 12 FPS, just because that's it's good enough to not feel too cluttered or too slow and hard to read. And so simply, if I click, let me just go into pose mode, click record, and then just rotate this a bit. It only records the frames that it detects, and I can quickly just save it. Just call this test. Save it, and it'll save that quickly. And if I go here, you see right away, boom, we have a amazing GIF. So that's what I do for my submissions, and I think that helps a lot. So I highly recommend GIFcam. And we are approaching. Oh, let me just make sure my audio's good. There we go. Okay. So we are approaching the end. Let's see. Scan your computer. What? Wait a minute. Let me double check that. I believe the website it has a lot of, oh. No, yeah. So, here. So, when I go to download it, so it's a bit sketchy, the website, but it's fine once you get it. If you click on free download, but the first time it might show. Let me just go back a second. Yeah. If I click here, oh, it's just downloading for me. Actually, I'll just go like search on Google, give cam, like this. And so right here is one I click on. And if I click on free download for Windows, it's gonna give a ad right away. But you're just gonna wanna like click out. And then you click free download again. Yeah, I mean, this is what I use. It might be not the most secure. If you have other ones you can recommend, then feel free to. Maybe I should do my research a bit as well, in case I have something that's not good for my computer. But yeah, this is the one I use. I think my voice is coming through good, but my recording, my video is a bit laggy right now. Let me just, there we go, I reset it. Yeah, so we are going to go through a rig, and then using kind of what we understand right now, we're just gonna figure out what this rig does, what we want from this rig for our own, and then how we can sort of plan out how we're going to rig our own models, right? And so the first thing I need to consider is, so I'm using, my plan for this semester is to make a proper rig for my boss character from last semester, or from last year, Crowan, because Crowan, I only created the deformation bones for him and then just passed it on to my animator for them to use different, like they didn't use Blender, they used a different animating tool. And so I never got the chance to make a proper rig in Blender for Crowan. So what I want to do is throughout this semester kind of take what we learned from these classes, these tutorials, and then just put them into Crowan here, just to kind of show you how you can apply it to your own models and maybe the things you might run into because it's your own models. So we're just going to look at a different rig, and because Crowan, first of all, if I go to back to my scene here, Crowan's a pretty big guy, right? If I get the, let me just scale that down. If I get just the Unreal mannequin, you can see that one, the Crowan's much bigger than the mannequin here and has much wider shoulders. It's just a very large proportioned model, right? And then there's also the sword here to consider, and the hair. We have these, like, this is kind of like some locks here, some dreadlocks. And so things like the dreadlocks, these silver necklaces here, those things might move a little bit, or might want some bones to move a little more, right? But for the most part, Chrome was built for function, for quick movement, and so a lot of his clothing reflects that, where it's less clothing and the clothing's pretty tight to the skin, so there's no reason to have to animate as much cloth for this. That was the goal, because when you're doing characters, or when you're doing characters in your games, you're not going to probably want to make the most incredible, as much as you'd want to, the most incredible cloth simulation, or clothed characters with a giant cloak or something, because that's going to take a lot of work to look good when you're rigging, and sometimes you just don't have the time, or sometimes it doesn't make sense for the character. If Crowan had a giant cloak and he's moving all across the scene, it's going to get really clippy and might go through him a lot, so it just doesn't make sense, right? So it's good to consider that he's a big guy and he has thin clothing, so the big focus is on just the gargantuous scale of him and making that, that armature work well. And so what I wanted to do was, I went on to the website here, that under resources tab in Canvas, there is the various Blender character rigs. You don't have to follow along like with this, but I'm just showing you what I'm doing right now. I went on here and I got the snow rig here because it has the broader shoulders than the rain model here. I was using this one before, but I figured that snow would make sense to cover and to look into if I'm making this Crowan rig, which Crowan needs a larger rig, right? And so here is that right here. And so I'd say I'll look at this for about 10-15 minutes, and then we should be able to call the class there, and I'll give you my final say on what we've kind of learned from this. So I've never looked at this before. This is my first time, so we're gonna get into this together. And first thing is, we have this giant tab here for the rig, and this has those bone collections, those visibility layers that we were looking at earlier, right? And so by default we have the main controls that are on only. If I click on them, which is the rig, and then I go into pose mode, you can see now they have their colors, right? And we can start to sort of mess around. And you can notice actually right away that, if I'm not mistaken, let's see. Oh, never mind. So you can rotate this and you can transform this. So there's no constraint for that. And you can also scale it. So there's no constraints for that, which I'm not sure if that's a consideration, like a design choice, or they just did not add a constraint, but you can do that, right? And so right now you can see, what is this bone where you're selecting right now, right? If I go into here, show active, IK wrist L. So as we were talking about earlier, the naming conventions, very important. They did put the slash, or not the slash, this sign instead of the underscore. So that's what they chose to do differently, but as long as you keep a specific naming convention scheme, like I usually do underscores, if you keep that consistent across your entire model, it's much better than flip-flopping. You can see also it's .L, so this is the left side of this armature. It's the actual body's left. So if I'm looking straight on it from Snow's perspective, the left side is .L, his left, right? And you see, as we saw, it's IK right now, so that means that our hand, we can move our hand, and the rest of the, like the elbow and then the shoulder move with it as well, right? And then we have the tweak bones. Tweak bones can, if we have any sort of twisting we want to do at the shoulder, we can just do that here, right? Or at the elbow, we can do it here. And just a little bit of movement as well. If you want to have just a little bit of extra movement where you feel like it's necessary to remove any sort of very structured movement, right? And we can even turn on the miscellaneous. I wonder what this is. There's this gear here. Oh, and I see in the tool we have pose options. Huh, that's cool. Right, so every rig has its own way of working, right? And so it's good to know that, like, you don't have to exactly replicate what you see in other rigs, as long as you can take what you need or what you want from it. That's what matters, right? And you can see here I found under item the properties. This is the custom properties tab, and so this one didn't have it, but this one does. You can see that this is these are drivers, and they are, if I toggle this boolean, it toggles the visibility of that limb, right? And that's good to troubleshoot or kind of get into the detail of what's happening here. And you can see we have, this is a bendy bone, right? And so if I take my arm here, you can see that all these bones move in relation to it, right? And so if I turn it back on, you see it's stretching out, right? And so what I'm thinking is, I do want some stretch for Kroan, but probably not as much, because he's supposed to be a more realistic kind of entity. So I don't want it to look cartoonishly squashed and stretchy, but it can help in quick movements to emphasize certain animations when you have a little bit of squash and stretch. But I'm not going to be moving it super far out, right? And you can see, I'm like, how do these broad shoulders work, right? Like, how does this rig respond to my movements here? Let me just pop back up the cloud rig. And I mean, the face rig is its own can of worms, right? Got all these different, these are the widgets, remember? The control widgets that are used to change the face a little bit, right? And this saves you from, right, here's a good example actually. So the eyelid here, I'm clicking G and it's only moving it up and down to the limits that it's set to. So I can't move it past this point, and I can't move it above that point. And I can't rotate it, like I can't move it to the side. It's stuck. And I can rotate it too a little bit. But there's a bit of clipping. It does not rotate in any other direction though. It's just right to left like this. And this one here does not have any constraints, but the eyelids do. And let's see if we can kind of follow down the hierarchy. So you see here we have MSTR, eyelid lower. You see there's a constraint on it. What is this constraint here? So this control widget has a limit location. Oops. So I turned it off, and you can see now I can just move this widget beyond this point. But what happens is you see the eyelid just doesn't continue on, because this widget is controlling a different bone. And I believe it's going to be, let's see, if I go to the armature itself, because this organization is really good, I can go to the rigging, I can turn this on, right? And so the rig, this is the actual deform rig here. And you can see we can hone in on the different parts here. Right, and then we have the eye lid here. Oops. I wonder where the, is this it? No. Evaluation time. I'm trying to look for what this is driving, and I'm pretty sure it's, is it this one? Yes, copy, is it copy scale? There's a bone in here. Oh wow. Yeah, this one's intense. Not sure I know exactly where it is, but there is this this widget that's controlling these different deformation, or these different control bones at the eyelid, and then those control bones are then controlling the deformation bones. But then having those separations helps a lot to keep organization and reducing any sort of destructive accidents from happening on your model rigging. You can see all this movement we have, and we can inspect it here, and we can see that, let's go to, is it this one? You can see these yellow dots, or these yellow bones here. When I move the leg up, it is keeping like that. This axis is directly facing down to the ankle here, right? No matter what, it's always facing towards the ankle. And then up here, remember this is going to be a quaternion because it's moving in many directions. You see, up and down, left and right. So it's much more complicated. These are all things we'll slowly figure out as we go on, right? This is all overwhelming. I never even did this much for my rig, so you know, just keep that in mind, that this is already a lot more than what we're going to probably have. So I'm just gonna hide some of this, right? But the main thing is we're making it very easy as the animators to inspect it without the clutter of all that, right? And then I can just refer to this model when I'm making Crowan, because he's not as huge as Crowan, but he has the broader shoulders, the broader build that I was hoping for, the larger face, right? And so we're gonna go slow. That's the main thing. You see here we have, this is a widget for the eyes. they both move with it, and then I can just move one eyes on its own. And yeah, so I think that's all I'm gonna cover for now. I wonder what these are. I don't know what these are. These applying poses. But yeah, I don't want to keep you anymore because, you know, that's kind of it for the first class. What I guess what I want to say is that, you know, you can easily get overwhelmed with this kind of thing. There's so much steps involved in making a rig that you can just get overwhelmed and be like, I don't know how I'm gonna ever do any of this. But the main thing is we're gonna go slow and build up our rig throughout our rigs throughout this semester. And you can see that I'm going to if you come to every single or most of the tutorials, you will see that I will be reporting my progress on making this Crayon rig. I'll show you by next week. I should have the deformation bones all created with the weight paints done and show you how that was done, right? I don't believe I will be doing walkthroughs on things. The main thing is that I'll be answering questions and helping you in class with your models and everything, but we can't do that as easily right now online, and there's not much to help you with yet. But I will be making this model rig and then showing you what I did each week as I'm working on it. And the main thing that you would have to be at the tutorials for are those three assignments, those three activities, lab activities we're going to be doing at certain points, and I'll keep you posted on that when they come up. But yeah, that's all for now. I'll give you the rest of the time if you want to like talk, hang out, do whatever, but you're more than welcome to leave now if you like. Thank you so much for your time. If you have questions, let me know. And yeah, that's all. Yeah, take care. Have a nice one. Have a good day, everyone. Be safe out there in the cold. You too. Have a good day. Love you too, Aiden.